Okay, you guys, so we're going to start on section 9.5 today, logarithmic functions. So we're going to discuss the relationship between logs and exponential functions. We're going to talk about what a logarithmic function means. So it says the first thing we're going to talk about is writing exponential equations with logarithmic notation and writing logarithmic equations with exponential notation. So we like to be able to hop back and forth between logs and exponents and just make sure that we understand the way we can rewrite them. Solve logarithmic equations by using exponential notation, and identify and graph logarithmic functions. Okay, so part B is probably going to be the hardest part. And then as we progress through this chapter on to 9.6, we'll do a little bit even more difficult logarithmic and exponential equations. So if we graph the exponential function, where the base is greater than 1, we get an increasing function as shown below. So this is kind of what we did in the last section, okay? Now, here we can graph a logarithmic function. So we can graph the inverse of the function as shown below. Okay, so here we have, this is our exponential function, right? So we see that this right here is our exponential function. And then right here, if you graph this on your calculator, we'll do that later on, this is what the inverse would look like. Notice it's being reflected across this line right here, right? So we have our line y equals x. So this line, y equals x, shows that these are mirror images of each other, okay? And remember, we talked about when they are reflections across that y equals x line, that's a way that you can graphically determine if two things are inverses. So this is the exponential, and this is the logarithmic function, okay? This inverse function is referred to as the logarithmic function. So that's what they're saying right here. So the red line is our logarithmic function. So let's define it. It says if b is greater than 0 and b is not equal to 1, then y equals log base b of x. This is what it means. It means x equals b to the y power. So for every x greater than 0 and every real number y. So basically what I've learned is, or what I was taught is, just think of a logarithm as an exponent. So the answer, when you say log base b of x is equal to something, that something is the exponent. Okay, so notice here, what it's equal to is y, and notice here, when we rewrite it, it's the exponent. Okay, so this is writing something as a logarithm, but this is what it actually means in exponential form. Okay. So let's write these as exponential equations, okay? So what we can do is, I like to do something called the swirly. So I oftentimes, by the way, I refer to this inside, what's inside the logarithm, I often will refer to it as the argument of the logarithm, okay? So what I do is I call this the swirly, okay? So this is a very non-mathematical, okay, I don't even know if that's how you spell swirly. It probably is with the EY, but whatever. Okay, so this is a very non-mathematical way to think about it, but this is how I do it. I start with 4. So I say 4 to this power is equal to that number. Okay, so I kind of go in this circular motion like this. Okay, so I say, let's try that again. 4, the base, remember this is our base right here. So I say 4 to this exponent, because remember we said whatever the logarithm equals, it's the exponent. So it equals the exponent is equal to 16. So 4 squared equals 16. Okay, so let's do the swirly on this one. 8 to this power is equal to that argument. So 8 to the -1 is equal to 1/8. Let's do the swirly. So this to that power is equal to that. So 3 to the 1/2 is equal to the square root of 3. So this is all true. These are all true statements, right? So 4 squared is equal to 16. 8 to the -1 is equal to 1/8. And 3 to the 1/2 power is the same as the square root of 3. So basically what we did is, this is how we can rewrite a logarithm in exponential form. So remember, all I'm doing is this. I'm saying log base b of x is equal to y. So remember that the logarithm always equals the exponent. Since this is the base, right? This, this is the exponent because it's what the logarithm equals, okay? So exponent, okay? So then this I call the argument. Okay, but in reality, it's what it's equal to, okay? So that's where they're getting this idea from right here, all right? So let's move on. So write the logarithm, write as a logarithmic equation. So now they're giving us in exponential form, and they want us to rewrite it as a log. So what we're gonna do is we're gonna say, okay, so what's it gonna be? Log base b, but what's my base? My base is 5. Okay, now remember, the exponent is always what the log equals. So I know the 4 goes here, and then 625 is the argument. And then I can do the swirly to double check my work. I can say 5 to the 4th is equal to 625. 5 to the 4th equals 625, which is this. So it works, okay? So now you guys pause the video and you guys try these next two. Try to rewrite these next two as logarithmic equations, okay? All right, so hopefully you guys unpause the video and you end up with log, what's my base? My base is 2, okay? Of 1/8 equals the exponent of -3, okay? And this is true. 2 to the -3 is in fact 1/8, all right? Let's do log base 4, right? Because here's my base. And then we're gonna say that it equals the cube root of 4. What's the exponent? 1/3. So remember, this is the exponent, so it always has to be over here with the equal sign when you're writing on the right side. Or I guess it could be the left, depending on how you write it. But you have to set the logarithm equal to the exponent. So in this case, log base 4 of the cube root of 4 is equal to 1/3. So the exponent is 1/3, okay? Remember, the logarithm equals the exponent, okay? So hopefully that went okay. Okay, some more practice. So now find the value of each logarithm. All right, so let's take a look here. So it says, now what you have to do in these is you have to set them equal to something. So I'm going to set them equal to y because they didn't tell me. Remember, the logarithm always equals an exponent. So I'm going to say 2 to the y is equal to 32. But 2 to what power would be 32? Wouldn't it be the 5th? So y equals, let me write it below it. So y equals 5, okay? Now let's do this one. 5 to the y is equal to 1/25. Well, we know that this is actually, 1/25 is actually 5 to the -2, right? Because that would be 5 squared is 25, but if you make it to the -2, it makes it 1/25. So here, notice we have 5 to the y, we have 5 to the -2. When the bases are the same, now we're going back to our exponential stuff. When the bases are the same and they're equal, then the exponents must be equal. So y must equal 2. Let's try this one now. So this one says 4 to the y is equal to 2. So we know that this is really 2 squared to the y is equal to, now you could guess the answer is already, we're pretty sure that it's 1/2 because 4 to what power would give me 2? Well, 4 to the 1/2 power would give me that, but I'm just going to use this. I'm going to use exponents. So this is 2 to the 2y is equal to 2 to the 1. So we just say 2y equals 1, divide both sides by 2 by 2. So we get y equals 1/2. Right, but I kind of knew that from the beginning just because I kind of could recognize it here. So sometimes you can see it right away and other times you have to do the math. What I did is I fell back on our old technique of exponents where we learned that as long as we have same bases, then we can compare exponents. Here my exponent's 2y, here my exponent is 1. The bases are both 2. So I just set the exponents equal to each other and solved. And I got 1/2, okay? So now let's look at this one. It says solve log base 6 of x is equal to 2. So now this is where they're not telling us the exponent, okay? They're telling us the exponent, but they're not telling us the argument. All right, so what we're going to do is they say rewrite 6 squared equals x. So what they did was, is they did the swirly. They just said 6 squared equals x. So 6 squared equals x. So then x equals 36, and you're done. Okay, so not too bad. So this, again, is a nice one, and most of the ones in this section are nice. When we move on to the next section, it gets a little bit harder, okay? So now we do the same thing. Solve log base x of 81 is equal to 4. So once again, x to the 4th equals 81. So we have x to the 4th equals 81. And they're showing you right here, but I just wanted to write it right next to it. And then you know that x to what power would give you 81? So 3 times 3 is 9, times 3 is 27, times 3 is 81. Or you could do this, right? You could 4 through, right? So you have x equals 3, okay? So it says right here, even though -3 squared also equals 9, the base b of a logarithm must be positive. So the solution set is 3. And that goes way back to here. The way we define logarithms, it says here for logarithms, the base must be greater than 0. So we don't really talk about logarithms unless the base is a positive number. Not to say it couldn't possibly be written that way, but the way we've defined logarithms is in this fashion, okay? All right, so let's go on to this one. So now I want you guys to try this one on your own, okay? So hopefully you notice the key is to rewrite it in exponential form. So the key to solving these type of logarithmic equations is using exponential form, right? So we want to convert it to exponential form because we know how to work with that a little better. We'll learn in the next section some properties of logs that will actually allow us to keep things in logarithmic form, and then we can solve that way. But for now, let's go 2 to that power is equal to that. So 2 to the x is equal to 1. Well, we know what's the only thing that you could take 2 to be that you would get 1 as an answer. Well, that's right, x equals 0. So anything to the 0 power is equal to 1 besides infinity and 0 itself. Okay, so hopefully that one wasn't too bad. All right. So here's a few properties of logs, and it's kind of emphasizing this example 10 here in one of these. It says if b is a real number and b is greater than 0 and b is not equal to 1. So again, this is just kind of reiterating that we're working with logarithms. Then log base b of 1 equals 0. And again, that's saying b to the 0 power will always be 1. So it doesn't matter what the base is. If it's equal to 0, the argument has to be 1. Okay, so what's inside? Because think about it. If you write in exponential form, doesn't matter what I put in for the base, b to the 0 power is always going to be 1. Okay, so log base b of b to the x is equal to x. So in a way, you might think about it like the argument and this cancel, but in reality, there's a property that actually says that log base b of b is equal to 1. And think about it. B to the 1 is equal to b, right? So that's the only way. Okay. So basically, they're just saying for this particular one, there's a property we're going to learn in the next section that tells us that we're allowed to take this exponent and move it to the front. The argument, if the argument has an exponent, we're allowed to move it in front. But for this one, they're just saying that this is going to be equal to x, okay? If you do b to the log base b of x, it's also equal to x. And once again, you think about these in a way, they're not actually canceling. There's a property that's saying that when you have a base to a log of the same base of x, it's going to equal to x. And again, if you tried to write it in logarithmic form, you would see. Okay, so these are properties that we're going to learn. There's going to be a bunch more in the next section as well. Okay, so in this one, let me see here. So this says, this says simplify. So log base 4 of 4 is equal to 6. Well, if we go, or I'm sorry, log base 4 of 4 to the 6, what does it equal? So, or simplify it. So we're going to come up here and we're going to notice that this is a base of 4. So this is property 2, right? This is a base of 4 with an argument that's the same value and an exponent. So they say just set it equal to the exponent. So this equals 6. Okay. Now this one is going to be this property, right? Where it says b to the log of b. So this is 7 to the log of 7. And then it says just set it equal to the whatever the argument was. Well, in this case, the argument was -3. So it's -3. Okay, so not so bad. So that was property 3. All right, so if x is a positive real number, b is a constant positive real number, and b is not 1, then a logarithmic function is a function that can be defined in this fashion, right? So log base b of x. So f of x equals log base b of x. The domain of f is the set of positive real numbers, and the range of f is the set of real numbers, okay? So here's why. So if we go back up here, all the way back up, if we look at our nice little drawing we had, way up here, this is log of some base, this in red, of x. So what this is doing is it's showing you the domain. Notice the domain, it only goes so far left, right? It keeps going downward, but it never crosses the y-axis, okay? It never crosses the y-axis. However, it constantly is going downward. Okay, it never goes away from that. And here it's going to the right, but it's also going upward. Okay, so that's why the range is -infinity to +infinity, but the domain is from 0 to +infinity. You can never get 0 and you can't ever have negatives. And it's the way that the logarithmic function is defined because the base can't be negative. Okay, so let's go back over here. All right, so here it says to graph logarithmic function, we first write the equation in exponential notation. Then we find ordered pairs that satisfy the equation and plot their corresponding values. Okay, so let's take a look at that. So it says graph the logarithmic function y equals log base 4 of x. Write the exponential form 4y equals x. Okay, so that's what they have here. X is equal to 4y, and this is y. So what I normally do, okay, then choose y. So normally, right, we normally choose x values, but in this case, it looks like you have to plug in the y to find out what x would be. So I'm going to plug in 1, 0, and -1 for my y's. Okay, so when I plug in 1 into this equation, right, and all I'm doing is I'm taking log base 4 of x, and I'm rewriting it in its exponential form. Remember, we said that's what the log means, is 4 to the y is equal to x. So I'm rewriting that. So x is equal to 4y. So if I take 1 and I plug it in here, I get 4. So that's where the 4 came from, right? If I take 0, right, and I plug it in, 4 to the 0 is 1. And if I plug -1 in, 4 to the -1 is 1/4. And then we plot these values. So we go over 4, up 1, that's this one right here. We go over 1, up 0, that's this one right here. And then we go -1. Oops, did I do this wrong? No. And then we go over 1/4, down -1. So that's right about there. And then we connect the dots. And you see it's the same line. I drew it. It should not go over the y-axis. It's just bad drawing on my part. Okay, and constantly going downward like that. So once again, the domain would be from, the domain would be from 0 to infinity, and the range would be from -infinity to +infinity, okay? And you could, once again, graph that on your calculator by doing y equals log base 4 of x. Actually, you know what? Hold off on that. Some of you have that feature, but I don't know if the TI-83 Plus has that feature. That's something I'll have to research. I know the TI-84, you can do any base on your TI-84 Plus, but I'm not sure about the 83 Plus, and I know some of you may only have that. So give me a minute on that one. Graph the logarithmic function f of x equals log base 1/2 of x. Write the exponential form. So we do that. So we said 1/2 to the y. Remember, all I'm doing is the swirly, right? So this is saying log of 1/2 of x is equal to y, or f of x, right? I'm renaming f of x as y, and then I do the swirly. 1/2 to the y is equal to x. So 1/2 to the y equals x, okay? So once again, this time, we're choosing our y's first. So when I plug 2 in, I get 1/2 to the 2 would be 1/4. I plug 1 in, so I'm going to use 1 now. I'm using 1. When I plug 1 in, I get 1/2 to the 1, which is 1/2. I'm plugging 0 in. I plug 1/2 to the 0, we know is 1. I plug -1, and now this does the reciprocal, so I actually get 2. When I plug -2 in, I actually get 4, okay? So now if we plot these, once again, I'm going to plot these with red. I will go over 1/4 up 2, so that's right about there. I'll go over 1/2 up 1, that's right about there. I'll go over 1 up 0. I'll go over 2 down 1, and I'll go over 4 down -2. Connect the dots once again, and we have another graph of a logarithmic function, y equals log 1/2 of x, log base 1/2 of x. Okay, so that's pretty much how you can graph them by hand. Again, we're going to learn a lot more in 9.6. This is just kind of the intro to logs, how to rewrite logs. And remember, a logarithm means an exponent. So you're saying log base something of something is equal to some exponent. So whatever you set the log equal to, that is the exponent. Okay, so that's kind of the big thing about this chapter. And then in I think it's 9.7. Let me see, I'm sorry, in 9.6, we're going to do a lot more properties of logs. So there'll be a lot more you have to learn in 9.6. That'll be the harder section of the two. 9.5 is the intro. 9.6 is definitely more of a difficult section, a really good test section where a lot of questions for the exam will come from 9.6. All right, you guys, thanks for watching, and see you in class.